In this video, we'll be covering the derivative of logarithmic functions. So at the top of your screen, you can see a recap of your logarithmic rules. It's important to remember these, and if you forget, it's a good idea to write these down. So the derivative of y equals ln x is just 1 over x. This only occurs when x is greater than 0. Now we also have the chain rule version of this, where y equals ln some sort of function fx. So you would differentiate fx, that is now your numerator, and your denominator is just your fx original. So again, 1 over x essentially. The derivative of log ax is 1 over x ln a, and the best way I think to go about this is to jump into some of the questions. Alright, so the first question we have is to differentiate x plus ln x. So we want to find dy dx. Now we know that the differentiation of x is going to be 1, and remember our rule, if we had dy dx ln x is going to equal 1 over x. So because we have plus ln x, we get 1 over, oh, not a plus, x there like that. Alright, and that's all there is to that one. You differentiate them as two separate things, so notice how we did the x and we got our 1, and then we did our ln x and got our 1 over x. Two separate things. Now down here, now remember with this one, ln fx x equals the derivative of fx over fx. Right, so knowing that, where dy dx is going to equal the derivative of what's in the brackets, so we're looking at this right now, so the derivative of that is just 8, so 8 goes on top, and on the bottom is our original function, so 8x minus 9. The 2, remember we do have to differentiate that, but because it is a 2 and there's no x value there, it just disappears. Now we're going to need to use the chain rule for this differentiation, because we have a bracketed area that is to the power. So we're going to say that y equals u to the power of 6, and u equals 1 plus ln x. So dy du equals 6u to the power of 5, and du dx equals, the 1 disappears because there's no x value, and remember the differentiation of ln x is 1 on x. So now we go down here and remember dy dx equals dy du multiplied by du dx. So we get 6 on x, u to the power of 5. We can substitute our u value back in, so we get 6 on x is 1 plus ln x to the power of 5. Alright, this time we're told to find the gradient of the normal to the curve, so remember when you're doing these type of questions, you always need to differentiate your function first. So if y equals ln x to the power of 4 plus x, we're going to need to use the chain function again. So we know that y equals ln u, and u equals x to the power of 4 plus x. So dy du equals 1 over u, du dx equals 3x power of 3 plus 1. We then multiply these together, and we get 3x3 plus 1 over u. We can substitute our u back in, so 3x3 plus 1 over x4 plus x. We were told at the point 1 ln x, so we know that x is 1, so let x equal 1. So we get 3 times 1 to the power of 3 plus 1 over 1 to the power of 4 plus 1. And this gets us 5 over 2. So that at this point, this is our m tangent, the gradient of the tangent. And if you remember, your m normal equals -1 over your m tangent. So -1 over 5 over 2, which ends up being -2 over 5. To end the video, we'll do a quick recap. Remember, if you can't remember your logarithmic rules, it's a good idea to write them down, and they're at the top of your screen now. Remember, when you're deriving y equals ln x, it's just 1 over x, and you do a similar thing when you're doing log of a function. You derive the function, that goes on as the numerator, and your denominator is your original function fx. Remember, the gradient for the normal is found by finding the gradient of the tangent first, and then it's -1 over the gradient of the tangent.